This video will be an overview for the process of creating a confidence interval. In the last video, we created a confidence interval for the population proportion. Now in this video, we will create a confidence interval for the population mean, usually written as the Greek letter mu sub x, where x is our variable of interest. Remember that a confidence interval will provide us with a range of values that we can be fairly confident will capture the true population mean. Let's use the same example. Recall my new product idea to develop a solar-powered charger for electronic devices. Also recall that I randomly surveyed 400 people at the local shopping mall for insight as to whether they would purchase my new product. Now, I also asked a second question as to how much they would be willing to pay for this new solar charger. Using the data from this survey question, I will be able to determine a range of values to consider for the selling price of this new product. If we look again at my survey, 50 people were interested in this product. I'm only going to focus on those interested people for my second interval. From the survey data, I found that the sample mean purchase price to be $24.75, and that included a sample standard deviation of $7. This is almost all the information I need to create the confidence interval, along with the confidence level. Again, we will use 95%. We will start with the formula for a confidence interval for a population mean, as you can see here. See, the point estimate for this interval is the sample mean, or x bar. It should make sense that our sample mean is our best estimate for the population mean. Our next input is our t-value. A t-value is very, very similar to a z-value, except that it takes into account the fact that we only have sample data to work with. So it allows for a little bit more variation than the exact z normal distribution. Go back again and think about that empirical rule for capturing 95% of the data that was equal to about plus or minus 2 standard deviations. Well, interestingly, the exact t-value for this interval works out to be 2.01. The alpha in the formula is the probability equal to 1 minus the level of confidence, or 0.05 as we saw before. The df in the graph stands for degrees of freedom, which is the sample size minus 1, or n minus 1. Thus, the degrees of freedom here would be 50 minus 1, or 49. The next input value is s, which stands for our sample standard deviation, which in this case was $7, or 7. Finally, we take into account the sample size n, which is about 50. Now all that we have to do is plug in the numbers and work out the interval. We start with our point estimate of 24.75, plus or minus our t-value of 2.01, times 7 divided by the square root of 50. That all works out to an interval where we have, on the low end, $22.76, less than the true population price that people would be willing to pay, which would be less than $26.74. So from this interval, we can state that we are 95% confident that the true population mean price that our target market would be willing to pay for the new solar charger is between $22.76 and $26.74. Note the application of alpha. With alpha equal to 0.05, that means that there is a 5% chance that the true population mean price is not contained within this interval. This is also a reasonably narrow range from our interval that we should be able to utilize to estimate how much to charge for our new product. Next, we will show how to use those two intervals that we created to estimate how much sales revenue we might be able to expect.